Okay, Unit 8, Day 3. So what happens if you have a triangle and you don't have an angle and side both given to you? Now what do you do? Well, that's today's lesson. So here's our warm-up. We have a triangle here, and if it's a right triangle, it's going to fit the Pythagorean theorem. So let's see if it does. So this question mark saying, let's see if it does. Again, A is opposite angle A, B is opposite angle B, and C is opposite angle C. 24 squared, 7 squared, 25 squared. No, A does not have to be the smallest one. Squaring each of these numbers, adding these two together, sure enough, it fits the Pythagorean theorem. Okay, looking at this triangle, doesn't look like it has a right angle, so we don't think it's a right triangle. So what if they give us numbers for this? So we have 44, opposite angle A. Again, you have to put the numbers in the right positions. 29 is opposite angle B, and 50 is opposite angle C. That's who the A, B, and C are, opposite their respective angles. Okay? So here's the thought. If it's a right triangle, like we just said a moment ago, it has to fit the Pythagorean theorem. But if it doesn't, then this angle is either bigger than a right angle or smaller than a right angle. If it's a right angle, it's a right triangle. If it's bigger than a right angle, it's obtuse. And if it's smaller than a right angle, it's acute. So that if the two sides squared is bigger than C, it must be a smaller C. If these two squared and add together is smaller than C squared, then C must be larger. And so then the angle that used to be a right angle is a little bit bigger than a right angle or a little bit smaller. Bigger, obtuse, smaller, acute. So in this situation, A squared, B squared, C squared, A squared, B squared added together. They're bigger than C squared. So C must be small, the psi is small, which means the angle opposite is smaller than a right angle, and so it is an acute triangle. Looks like here that C is bigger than a right angle, and so then this should be bigger than these two squared. Let's see if it does. So here is A squared, B squared, C squared, 36, 49, 121. Adding these together, we get 85. The C squared is bigger, which means C is bigger than it would be if it was a right angle. And so we have an obtuse triangle. And we're off by, if it was a right triangle, I'd have 85. But this is bigger by 36. So they're going to tell us that angle C is approximately 115.4, angle C. And then they're going to give us this wacky formula. 2ab cosine C. Everything's covered. Side A, side B, and the angle between them, angle C. And lo and behold, for some bizarre reason, this crazy formula gives us how much we're off by, more or less. Now for our right triangle, we are right on. The Pythagorean theorem fits. Well, let's see. If I take AB and cosine C in this wacky formula, well, cosine of 90 is 0, anything times 0 is 0. Well, yeah, we're not off by anything, because here the Pythagorean theorem works because it is a right triangle. So you might call this our fudge factor. So let's see. If we take our Pythagorean theorem and subtract the fudge factor, it should work. Now notice the relationships here. Here is side C and here is angle C. The other two sides are there and also here. So depending on what we're given in the situation, maybe we want side A here and angle A here. The other two sides are B and C, aren't they? Or maybe I want side B here and angle B here, so the side and opposite angle will always be at both ends of the formula, and then the other two sides are A and C, A and C. This is, as we can see in the next page, the law of cosines. Key, side, opposite angle, side, opposite angle, side, opposite angle. Really, even though there are three of them, there's really only one. Side, opposite angle, and the other two sides. And it's the law of cosines.